Hi, in this video we will learn how multiplying a scalar to matrix changes the determinant. Well, remember that when you multiply a constant to a square matrix, or in general, every entry or every row of A is multiplied by C. In other words, let me just write it like that. If A is our row 1, row 2, up to row n, well, these are just rows, yes. Then CA is going to be like CR1, CR2, and CRN. Now, if you're finding the determinant of CA, well, we have to multiply every row by 1 over C to get into the matrix A. In other words, we have to factor out C from each one of these rows, and each one will give us 1 over C, so it will give us C for row 1. This another C row 2, another C row 3, and so on up to row n. How many of these we have? N of them. Then the matrix, well, let me just then draw this row operation as we have this, is A. How many of these guys we have? N of them. It means that we have Cn, determinant of A. So when you multiply, this is a fact now, this is a theorem, I just proved it for you. For a square matrix, let A be an n by n matrix, then determinant of CA is not just C determinant of A. This is C to the power n. The number of rows appear there as the power of C. Okay, so that's the property, how scalar multiplication changes determinant by a constant C to the power n. Let's do some examples here. Just yes, okay. Here I have a 2 by 2 matrix whose determinant is 3. What is determinant of 5A? Well, this guy, you have 5 times A. This, in other words, this is C. And we know that scalar multiplication, to come out of the determinant, you have to put the number of rows as power of that scalar. So this is 25. Determinant of A is 3. So 3 times 25 is going to be 75. How about determinant of negative A? Well, negative A is same thing as multiplying negative 1 to A. Yes, so that is C here. So then negative 1 to the power 2 comes out. This is determinant of A. And we know that negative 1 to the power 2 is just 1 times 3 gives us 3. How about this one? Determinant of A times A. You see, determinant of A is a number, so we can take it as the scalar that we are multiplying to A. And we know that scalar comes out of determinant, whatever C is, but we have to put it in the power 2. Well, here, C itself is determinant of A. In other words, we have determinant of A to the power 2 times determinant of A, which is determinant of A to the power 3. So 3 to the power 3, which gives us 27. Without knowing the dimension of matrix, you cannot say what is determinant of 5a just by knowing determinant of a. You need to know what is that n, otherwise the formula doesn't work. And that brings us to the next and last example, which says, okay, if you know how determinant changes in the scalar multiplication, you might be able to find the dimensions of the matrix. So here, determinant of A is 3, and the determinant of 2A is 24. Well, determinant of 2A is 24. But what we know is that determinant of 2A is equal to 2 to the power, whatever the dimension of this number of rows of this matrix A is, and times determinant of A. In other words, we have 2 to the power n. Well, determinant of A is what? 3. This is going to be equal to 24. Well, divide that by 3, so you get 2 to the power n equals to 8. 24 divided by 3. What is the power of 2, which gives us 8? Well, 2 to the power 3 is equal to 8. That means that, well, maybe I should have put that in bracket. That means that n is equal to 3. So A is a 3 by 3 matrix. And that's the result we have here. Well, this was very quick. One of the matrix operation, which is scalar multiplication, we see how that changes the determinant.